Welcome to section 5.3. We're going to be solving some radical equations. It's going to be a little bit different from solving regular equations. We'll talk about that now. When you solve a radical equation, you must identify restrictions on the variable. So we've been hinting at that through the first two sections of this chapter, but here we're going to need to do it regularly. And the other thing that's different is we're going to have to identify any of the roots are extraneous by determining whether they satisfy the original equation. And you might be thinking, well, why wouldn't they satisfy the original equation? And it has to do with the nature of the radical, because in practice, when you square root something, for example, you have two possibilities. That means that we may end up, in some cases, with a solution that comes out of our solve that will not actually work in the original equation. Yeah, and we will look at that in the next video. In this video, everything's going to be semi-normal. Okay, so let's scroll down. I want to get that part out of the way. And we're going to solve an equation with one radical term. All right, so let's start with the restrictions. In this case, we've got a square root of 2x minus 1. So because that is an even index, our only restriction, is going to be that 2x minus 1 has to be greater than or equal to 0. Right? So this radicand, 2x minus 1, can't be negative. So if 2x minus 1 is greater than or equal to 0, 2x is greater than or equal to 1. If I add 1 to both sides, if I divide by 2, then x is going to be greater than or equal to 1/2. All right, so when we solve, we're going to have to come back and make sure that our solution meets our restriction. Now let's go over to the solve. Okay, so we've got 5 plus the square root of 2x minus 1 equals 12. And our order of business here, since we've just got one radical, is going to be to isolate that radical. That way we can square both sides and make the radical go away. Okay, so to do that, I'm going to take 5 away from each side. And I'm going to wind up with the square root of 2x minus 1. Hold on there. I changed my pen tool. I don't think I like it. Let's go back to the brush. All right, and I'll go back to blue. Okay, so we're going to subtract 5 from both sides, and when we do that, we get that the square root of 2x minus 1 equals 12 minus 5, which is 7. Okay, and at this point, all that's left to do is going to be to square both sides. So I'm going to square the square root of 2x minus 1, and I'm going to square 7. When I do that, this is going to be, squaring undoes square rooting, 2x minus 1, and on the other side, 7 squared is going to be 49. Now to solve, I'm going to add 1 to both sides, so 2x equals 50. And then last but not least, I'm going to divide both sides by 2, so x equals 25. Okay, so that's our solution. We have to check now, does it meet our restriction? Yeah, it meets the restriction. 25 is greater than or equal to 1/2, so meets restriction, check. Meets the restriction. X is greater than or equal to 1/2. All right, so that leaves us with the verify. In this case, the verify is going to work the way you would expect it to. When we verify our solutions, we're going to verify the x equals 25. We always go back to the original equation. So we're not going to go back to where we did anything to it. We're going to go back to the original. So we're checking to see if 5 plus the square root of 2 times 25 minus 1 equals 12. Nothing terribly interesting on the right-hand side. Left-hand side, we work in the brackets. It's going to be 5 plus 2 times 25 is 50, minus 1 is 49. So 5 plus the square root of 49 is 12. Square root of 29, or 49, if we just think the positive root, is going to be 7. 5 plus 7 equals 12, and 12 equals 12. So our verify has worked, and our solution is x equals 25. Okay, this is kind of the simplest case. We'll do a trickier one here, and that was part B, in the next video.